All right, so today we are going to start talking about one of what's called a special right triangle. And so hopefully you guys started to kind of take a look at some of these before you watched the video so that you could kind of start looking for these relationships here. And so I kind of started both of these. And I'm just going to talk through some of review some of these steps when we're working with radicals here. So when we set up the Pythagorean theorem here, we've got our legs and our hypotenuse, so there's our variable. When we square 15 and 15 here, we get 225, right? So that means that this is a perfect square. That's a perfect square because we're going from here to here. So when we are solving for x by taking the square root, since I added this perfect square twice to get that, that means that 450 is divisible by that perfect square. So I can break that down to 225 and 2. Well, the square root of 225 is 15. I'm going to write this answer up here. And then I've got that radical 2 that's left underneath the radical. So that would be the missing side. Okay, so now let's go through this one. So we've got 3 squared, which is 9, plus x squared. Now remember, for this, we square both parts of this. So 3 squared is 9. Radical 2 squared, that'll cancel out. So that just leaves us with 2. So that's going to be 18. You can get that by just typing that in your calculator as well. And so then 18 minus 9 is 9. And when I take the square root, I get 3. So that side's going to be 3. So now I just want you to kind of look at both triangles and just see, what do you notice and what do you wonder about it? So hopefully you notice that the lengths of the legs, which is the two non-hypotenuse sides, are both the same. They're both 15 here and they're both 3 here. So now let's think back to first try. What does that mean about the types of triangles? Well, if we've got two congruent sides, that means that both triangles are isosceles triangles. So when we think back about what that means about the measures, right? So if we are working with two isosceles triangles, we have to remember that the base angles are congruent in an isosceles triangle. Okay, so if we know that this is a right triangle, that means that 90 degrees is already spoken for. So then if we've got 90 degrees left to split between the two, that means each angle has to be 45 degrees. And then if we look at how the legs and the hypotenuse are related to each other, it's always the length of the leg times the square root of 2. Which, if we think about why that is, it's related back to the Pythagorean theorem, right? If we're working with these isosceles triangles, this part of the Pythagorean theorem is always going to be like 10 squared plus 10 squared, or 5 squared plus 5 squared, or 20 squared plus 20 squared. So that means that you're always going to have the sum of the same number added together to get that. So when you take that radical, it's always going to be the square root of whatever that number is with that multiple of 2 left under. So that is always going to be the relationship between the sides of what's called a 45, 45, 90 triangle. So it all relates back to the Pythagorean theorem and properties of isosceles triangles. So if you're working with a right triangle and you know that it's isosceles, and you can tell that by either looking for the congruent markings on the sides or the congruent markings on the angles. So like here and here. Okay, and so if we've got the length of the sides will always be the same. So just whatever value, numerical value. And then the hypotenuse is always going to be radical 2 times as long. Okay. All right, so now let's just we're going to look at just a bunch of different examples here of different things that we could be given to help us find these measures. So here again, we know that it's 45, 45, 90. We've got our angles measured here. So 8, we can know that's 8. And then the hypotenuse is always radical 2 times as long. So x is just going to be 8 radical 2. So honestly, for most of these, there's not going to be a lot of work, especially when you know one of the legs, because all you'll be doing is multiplying by radical 2. Sometimes, though, we'll have to work backwards. So this right here, this is our hypotenuse. So we have to think, okay, if I'm looking for x right here, I have to think about what did I do to get radical 8? So I took whatever that side is, and I multiplied it by the square root of 2. And that's how I got 8. Just like here, that side was 8. I multiplied it by the square root of 2 to get the hypotenuse. So whatever this is, I multiplied it by the square root of 2, and I got 8. Okay, well here, in order to get that x by itself, I have to divide by the square root of 2. I have to undo that multiplication. And so here, if you watched the entire 8.3 lesson video, I briefly mentioned what we're going to be doing in this lesson and next lesson, which is called rationalizing the denominator. So you cannot have a radical in the denominator of a fraction. It's just not fully simplified. And so what we will always do to rationalize is multiply the numerator and denominator by whatever that radical is, which if you're working with 45, 45, 90, should always be the square root of 2, since that's always the relationship between the leg and the hypotenuse. So now what we have, should have started this up here. In my numerator, I have 8 radical 2. And then when you take the square root of 2 times the square root of 2, the radicals cancel out, right? Because that's going to be the square root of 4. Square root of 4 is 2. I'm sorry. The square root of 4 is 2. That should be a 2, not a 4. And then I got the 4 because then we will simplify the 2 common parts. So you won't simplify the part that's under the radical, only the parts that are outside. So that means that this is going to be 4 radical 2. And that would be the length of the 2 legs. Okay. Now, as we do more of these, I want you guys to kind of also look at like shortcuts and kind of noticing numerical patterns. And so just kind of thinking about, all right, so if we got 8 here, if that was the hypotenuse, and this is 4 radical 2, I just want you to kind of keep this in mind as we look at some of these other examples about the relationship between those numerical values here. All right, so if we look at this one now, we've got, this is 14. This is a leg. So if this is 45, 45, 90, that means that x is also going to be 14, and y is going to be 14 radical 2. Leg times radical 2 is hypotenuse. All right, so now in this one, so let's work through this one kind of the long way, and then we'll maybe think about the relationship between these two. Because again, I know the hypotenuse here, I'm looking for the 2 legs. So now I have to think, all right, well, whatever the length of that leg is, multiplied by the square root of 2 is going to give me 18. So in order to get that x by itself, I need to divide both sides by the square root of 2. So that'll cancel out here. Come up here and finish this. All right, well, I can't have this radical in the denominator of the fraction, so I'm going to have to multiply the top and the bottom by that. So that means that I would have 18 radical 2. Those two radicals will cancel, leaving us just with 2. Right? The square root of 4 is 2. And then that will simplify to 9 radical 2. So both legs would be 9 radical 2. Okay, so now if we look here, we've got 8 and 18, and then we had 4 radical 2 and 9 radical 2. So I'm going to draw another one down here. I'm completely drawing a scale, but oh well. And I want you to see if you can figure out the length of these two legs without going through necessarily all the math. So pause the video, see if you can do it. Okay, so if you came up with 5 radical 2, then that's right. Okay. And again, the reason for that is we have to think about, okay, we have to multiply this by the square root of 2 to get that. So I need to figure out like 5, so because it's going to be related to 10, kind of like splitting it in half a little bit. And then it's just always going to be that radical 2 left under. So if this had been a 14, these would be 7 radical 2. If that were a 40, this would be 40 or 20 radical 2. So it's always going to be divided by 2 times the square root of 2 anytime. If it's an odd number, then your leg would just be a fraction. So if that were 11, it would be 5 radical 2. Oops. Or you could write that as 5.5 radical 2. It's just technically more like mathematically literate to write it as a fraction. Okay. All right. So now this last one, we've got our leg. So now we've got a radical in the leg. So we'll look at how that relates to that, and also kind of how that relates back to when we were going back from a hypotenuse to leg. And so we know that the other leg is going to be 4 radical 2. That's the easy part. And so then if m, the hypotenuse, is always the leg times the square root of 2. Well, when I do that, that's going to be 4 and multiply like part, so times the square root of 4. The square root of 4 times is 2. 4 times 2 is 8. So if you notice, it's kind of just backwards of this one. And that's, again, always going to be true if this is a radical 2. Okay, if it's not a radical 2, that will change things. You'll just have like radical 6 or radical 7 or something like that underneath. But when you have that radical 2, you really just multiply that outside number times 2, and that'll give you your hypotenuse. All right, so then this last question is just like an extension of that. So this is telling us the perimeter of a square is 48 meters. So if we remember anything about a square, all 4 sides are going to be the same. So 48 divided by 4 is going to be 12. Okay. So those would be the lengths of the legs. And so if I want to know the length of a diagonal, we have to know how to interpret that. Well, we know that a square has all right angles. And since all four sides are congruent, this is an isosceles right triangle, making it 45, 45, 90. And so if the 12s are acting as the legs, then that means the diagonal is just going to be 12 radical 2. Just multiply by the radical 2. Okay. So again, just hop on Canvas Conferences if you have any questions. Your homework assignment is the 45, 45, 90 part of the packet.